Hello GeoData people. So we're about to start Unit 5 in our new workbook, and you recently took a pre-assessment, a readiness assessment, giving you just 3 problems that sort of anticipate what we're going to be doing in the new unit. So I'm going to go over those 3 problems right now in this video and show you how you should have solved those problems if you knew how to do them. So the first problem says that Zuleika drew out a route that she will hike over a 3-day period onto a coordinate grid. This is an XY coordinate grid. And she's going to hike from point A, which is down here, to point B, and then from point B to point C. And on the 3rd day, she's going to return from point C back to where she started at point A. And the question is, if each grid unit, if each square on the grid is 1 mile distance, what is the distance she will travel between point C and point A? So you may notice that this looks like a right triangle, because on a coordinate grid, the x-axis and all the lines that run horizontally are at a 90-degree angle to the y-axis, and all the lines that run vertically. So this is a right triangle. So what we have here is triangle A, B, C, and she's going to walk from A to B and then B to C, and that's a right angle, and then she's going to return along that segment from C to A. Well, look, this is a right triangle. AB and BC are the legs, and AC is the hypotenuse. So you may remember the Pythagorean theorem, a squared plus b squared equals c squared. That is exactly how you would solve this problem, okay? So we know, abbreviating Pythagorean theorem, we know the legs would be the A and the B, and the length of the hypotenuse would be the C in this equation. And when you look at a coordinate graph like this, you can find the distance between A and B very easily. You just count how many units you're moving along that straight line. And to go from -4 to +4, you're traveling 8 units. So A, which is one of the legs, is going to be 8 units, and we square it. The other leg starts down here at -6, and it goes all the way up to +9. And if you count all of those, that's 15 units. So our equation is 8 squared plus 15 squared equals c squared. So 8 squared is 64, and you can do this on a calculator if you don't know it in your head. 15 squared is 225, and if I add them, that should equal c squared, my hypotenuse squared. So 64 plus 225 is 289, and that's c squared. So remember, we need to square root that. Square root of c squared is c, that's what we're looking for. And the square root of 289 is 17. 289 is a perfect square. So in other words, 17 units, and they're using miles, so 17 miles would be how far she would hike from A to C. All right, now I'll show you why you're going to want to do that. In this new unit, we're going to be studying circles, and one of the things that we're going to be studying, so I'm going to give you a sneak preview of one of the problems in the new workbook. Okay, from lesson 2 in the first investigation, we're going to be looking at circles, and one of the things that we want to figure out is the distance from the center here to one of the points. Well, look, if we want to know the distance from the center to, say, point H here, that's easy. It's right along the x-axis. We would just count how many units we traveled along the x-axis, and that's exactly 5. We could do the same thing if we wanted to know how far it was from the center to say point E, because again, straight along the y-axis, we would count the units, and it's 5. But what if we wanted to know how far it was to point F from the center? Well, we don't know. It's going cross country. It's cutting across the diagonals there, so we can't measure the units. But look at what we have here. We can make a right triangle. We can draw a triangle using the grid lines. It's a right triangle. And we can count how many units. And we can see that there are 1, 2, 3 units along that leg. And then coming up the side, we can see that there are 1, 2, 3, 4 units. And then what would we do? We would do a squared plus b squared equals c squared. The legs are 3 and 4. We don't know what the diagonal hypotenuse is, and we can solve it. Sorry, guys. A squared plus b squared, right? A is 3, b is 4. So 9 plus 16 is 25. Square root it, and c is 5, okay? So, big surprise, it's 5, 5, 5, 5, right? But that's why we're starting with a reminder of how the Pythagorean theorem works with right triangles. We're going to be doing a lot with circles where we look at those right triangles that are inside those circles, okay? So that's a little sneak preview of what we're going to be doing. Okay, so let's go on to the second problem that you had in that readiness assessment. And again, this is a reminder of some things that you had done in earlier units. So the second problem looked like this. You had a circle and you had chords PQ. A chord means it's a line segment that connects 2 points on the circle. So from point P to point Q is called a chord. And down here from point S to point R is also a chord, okay? And they're saying that those 2 chords are parallel to each other. And they're telling us this angle is 40 degrees, and they're asking us how big that angle is. Well, don't let the circle confuse the situation. We have 2 lines that we know are parallel, right? Remember the little arrows mean parallel. And look at what we have. We have a transversal that's cutting across the parallel lines. And remember, this is an angle pair, right? These are alternate interior angles. And in an earlier unit, we learned that alternate interior angles are congruent, meaning they have the same measure. So if this angle is 40 degrees, this angle is 40 degrees. Just because it's inside a circle, they still are parallel lines with a transversal. Those would still be alternate interior angles, 40 degrees. Okay, the last problem you had on your readiness assessment was about unit conversions. So Tiana has something that's 4 feet long, and she wants to know how many inches that is. So we need to convert from feet to inches. So we need to know how many inches are in a foot. So 12 inches is equal to 1 foot, right? Think about a foot ruler, right? When you look at a ruler that has inches on it, and the ruler is 1 foot long, and it has 12 inches on it. So if we wrote a fraction, if we wrote 12 inches divided by 1 foot, because these are the same, because these are equal, that's basically the same as saying 1, right? The value of 12 inches divided by 1 foot is 1, because we're dividing a number by the same value, right? Like 4/4 or 10/10, right? 12 inches is the same as 1 foot, so that equals 1. Now, why do we want to do that? I'll show you. She has 4 feet as a measurement. I'm going to use FT as an abbreviation. Okay, we want to change that to something with inches, okay? So we want to multiply this times something over something. We want to cancel out the feet and bring in the inches. So if I multiply this times 12 inches over 1 foot, this means I'm multiplying times 1, so I'm not changing the value of the 4 feet. But look at what happens. The feet and the feet cancel, and what I'm left with is 4 times 12 inches, or 48 inches, okay? So of the four choices, she's taking her 4 feet and she's multiplying it times 12 inches over 1 foot. It would be the first answer, and that would give you an answer of 48 inches. All right, so let me give you one more example. What if, for example, we wanted to work with metric, like many of the countries in the world do besides the US and the UK? So what if we wanted to change, say, meters to kilometers? Okay, so to change meters, which are written as M, meters are M, to kilometers, kilometers means 1,000 meters. Okay, it's written km, and there's 1,000 meters equals 1 kilometer. That's what kilo means. It means 1,000. So let's say we have a distance of 1,700 meters, and we want to change that to something in kilometers. We don't know how many kilometers. Well, here's what we would do. We need to cancel the meters and bring in kilometers. So we want to multiply this by something with kilometers divided by meters. Okay. So what's the equivalent? 1 kilometer is the same as 1,000 meters. So this has a value of 1, right? Because 1 kilometer is the same value as 1,000 meters. So this is, we're multiplying our 1,700 meters times 1, basically. But let's see what happens. The meters and the meters cancel, and we're left with 1,700 kilometers divided by 1,000, which is 1.7 or 1.700 kilometers. Final answer. Okay, so there's going to be sections in our new unit, in our unit 5, where we do need to convert units to other units, and this is the procedure that we're going to be using. All right, you'll get more practice on this later. That's all, guys. Bye.